This is a re-recording of the Day 1 lecture for Introduction to Computer Science 2, CISC124. I'm re-recording this video because the audio did not record in the lecture hall. So I'm Dr. Burton Maw. My office is in Goodwin 754. If you go up the elevator to the 7th floor, turn left, go through the double doors, and then turn right, you'll find my office. I have in-person office hours, Monday through Thursday, from 1:30 to 2:30. Occasionally, there will be one Thursday office hour per month that may need to be moved or canceled so that I can attend some departmental meetings. You can contact me via email at burtonmaw.queensu.ca. If you contact me by email, please put CISC124 in the subject line so I know what course you're in. I teach lots of students in many different courses, and it's very inconvenient for me if you try to contact me by email and don't put the subject line in. Teaching assistants, you'll have 7, I believe, in this section. Their information will be on OnQ later in the next week. They'll have office hours, so each TA should have 1 office hour per week. That'll be on Microsoft Teams, where you can join a Teams meeting and ask the TAs about questions, either about the course material or about the assignment material. All that information will be on OnQ shortly next week, sometime next week. Most of the course information, well, all of the course information is on OnQ. Lectures are recorded. Sometimes, as you'll note, the lectures don't record properly in class, and I have to re-record them. But they'll be posted on OnQ as they become available. There is no required textbook for the course. Instead, there's a set of online interactive notes that I'll demonstrate a little bit later in the lecture. The link to the lectures, to the online course notes, you can just use that link there. It's also on OnQ. If you want an alternative source of information, the library has some excellent books that are available to you online. The first book here is quite good for most aspects of the course. It has very good exercises in it if you are looking for programming exercises, especially for students in science and or engineering. The second book is written by one of the architects of the Java language. It's very highly recommended reading if you think you might be pursuing a career that involves Java programming later on. There are no labs for this course, even though they were scheduled into your timetable. The department has decided to remove labs starting next fall, going forward. And so we're not doing the labs this term either. Grading's on OnQ, and I'm going to show you all of this in a moment. Assignments. So there are 6 assignments. They're to be done individually, submitted via OnQ. So you're supposed to submit your own work. Of course, you can talk to your fellow students, discuss how you might approach the problem. You can talk to the TAs during their office hours. You can contact me about assignment questions as well. But if you do so, please try to do so during office hours rather than doing it over email. However, you are supposed to do your own work. We're using what's called a universal accommodation policy in this course. So every assignment has an official due date for each every assignment has an official due date. The expectation is that students will submit their work by this due date. And then the next assignment typically comes out shortly after the previous assignment is due. Now, if you don't finish your work by the official due date, you may submit your work up to 7 days late without penalty, and without needing to inform the instructors or the TAs, or going through arts and science and applying for an academic accommodation. You don't need to do any of that. Just submit your work up to 7 days late, and your work will get marked. However, you should note, if you submit your work, then that work immediately becomes eligible for grading. So that means 1 minute after the official due date, a TA could start grading the work that's been submitted under the assignment. If you try to make changes to your submitted work during the accommodation period, then they will not be considered if your work has already been evaluated. So do take care of that. You might be able to change your work and get away with it, but on the other hand, you may change your work only to find out that someone's already marked it and we will not reconsider your newly submitted work. You have 2 quizzes. We will set the dates for those quizzes shortly next week. They are in class. For this section, quizzes will be written in Chernoff Hall, so during the Wednesday lectures. There is an official quiz policy. We are going to update that on OnCue for you. If you miss one quiz for some valid reason, the weight of that quiz is shifted to the exam. If you miss both quizzes, we're still trying to determine what exactly the policy will be. Again, we'll update OnCue so that you can see the policy for what happens if you miss both quizzes. Finally, there is an exam in the course, and that exam is in person, scheduled by the exams office, held during the regular exam period. Accommodations for the exam are handled by the usual arts and science process. All of your quizzes and your exam are in pen and paper. So they do involve writing code and answering questions about the course material, but you have to, but they'll all be done written by hand. All right, so let's just quickly look at the OnCue, so I can course OnCue, so that I can show you around, and you can see where things are located. So here's your course homepage. There's my contact information right here. There's my office hours. The TA information will be here, and a link to the Teams channel for the TA office hours will be put down here. Under content, you'll find under course description and requirements, you'll see course policies here. So this is the common syllabus information. This is the what's in every computing science course, what's in the syllabus for every computing science course, sorry. Course descriptions here, this is basically the calendar description. Learning outcomes, again, part of the calendar description. Textbook information's here, and then the grading scheme is here. So you can see that assignment 1, because it's a shorter assignment, is worth 5% of your course. It's worth a little bit less than the remaining 5 assignments, which are each worth 8%. Both tests are worth 15% of your total mark, and then the exam is worth 25% of your total mark. The late assignment policy is here, and the missed quiz policy will be updated down here. If you go back to content under lectures, you'll find all of the lecture slides. So all of the lecture slides for the course are here. You'll find a link to the online course notes here. And there's a link to the YouTube playlist containing the lecture files. And so all the recorded lectures will appear under that playlist. Anything else? I don't think there's anything else. There are assignment and quiz solutions appear here when they're ready. There's a sample exam here, although that's probably out of date at this point. I might have to update that. Your assignments, of course, under assessments will appear here. They're not on OnCue yet. And I think that's all you need to know for the OnCue website. So now what I'm going to do is I'm going to click on that link, and I'm going to show you the online course notes. Oh, sorry, let's not do it that way. I'm going to right-click on that link, open that in open a new tab. So the course notes are running on a server somewhere in the world. They're hosted for free. So this one it actually loaded fairly quickly here. If the notebooks are being used with some regularity, then they should load relatively quickly. If for some reason people aren't looking at the notebooks, then you may find that it may take a few minutes for this site to load. And that's because, again, this is running on someone's server somewhere in the world for free. So if people haven't been using the notebooks for a while, then the environment that the notebooks get run in, normally it gets wiped off the server. And so whoever's running the notebooks has to reconstruct the environment that the notebooks are run in. So the notebooks are run in a framework called Jupyter Notebooks. You may have seen them before. If not, they're most commonly used for Python and other, I guess Python There's a language called R that uses Jupyter Notebooks as well. It's less commonly used for Java because there's no built-in support for Java. So I'm actually using a third-party set of what are called kernels to run Java in the notebooks. So when you open up the notebook, you'll end up on what's basically the table of contents. So these are all of the notebooks. Each link is a separate notebook. Each notebook contains information about a particular topic, right, which you can see here. You can see there's lots of notebooks, and when you click on a notebook, you'll see that some of the notebooks are quite long. So there's no way we can actually cover all of this information during the lectures. And so in other words, what I'm saying is the notebooks contain a lot more information than what the lectures could possibly convey. And so you're not responsible for all of the material in the notebooks. You're responsible for the materials that's covered during the lectures. But if you need another reference or a second reference for the material that we cover during the lecture, then you can always refer to the corresponding notebook. So let me just click on one of these links here. So this is basically Hello World in Java. So when you open a notebook, you'll see what looks like to be a web page. You'll see that there's text, which you should read, obviously. Right? And then every once in a while, you'll come across a cell that's shaded in gray. So these cells are called code cells, and you can run them in the notebook. So depending on your web browser and exactly which server the notebook is running on, you might see something a little bit, you might see a little play button here. I don't have it right now. So if you click in a cell, you can run the cell either by pressing the run button up here. You can also press Control and Enter at the same time in the cell. So if you run a cell, the cell will actually run. So the code in the cell will actually run. So %, Python indicates that this cell is a Python code cell. And that line there is a line of Python code. So that's Hello World in Python. And you can see when you run the cell, it actually prints Hello World. The really interesting thing about the notebooks is that you can edit the notebook. So for example, you can come in here and change the message that's printed. Right? So I can say something like goodbye world, whoop, and rerun that cell. And then the cell will run, and you end up with a new message, goodbye world. And so you can do the same thing for Java. So here's the Java equivalent of the Hello World program. I can run that cell. And now you'll see that the output here is probably not what you'd expect. So what's happening here is this is actually a complete Java program. So there's a class, there's a method called main. So when you run a code cell containing a complete Java program, the program doesn't run. Instead, the class here gets compiled. And the output that you see here is the output of the compiler. Null means that there was no output from the compiler, which in this case means that the program compiled cleanly. After you've compiled the program, you can then run the program. So if you go down to this cell here, this is the cell that actually runs the program that was contained in this cell here. So in this cell here, I'm actually calling the main method of the Hello World class directly. And now you can see the message Hello World. Right? And just like the Python code cells, you can come into one of these Java code cells and edit them, or edit the content, sorry, run the cell to compile the cell, and then run a second cell to run the program here. Now, if you have an incomplete program, then the cell will run just like a Python cell, which is nice. So you don't have to create complete programs in a Jupyter Notebook cell, which is really useful for learning, right? You don't have to go through the process creating the class, creating a main method, compiling it, and running it. You can just run a code cell containing containing an incomplete program. So for example, let me just jump ahead to a notebook here. So let's jump ahead to the arithmetic notebook. Right. At the top of every notebook, you'll see there's a cell up here. It's convenient to run the cell because running that cell will suppress some output that's normally not needed, is not needed. Okay, so here you can see there's quite a large code cell, right? But it's not a complete Java program. There's no class, right? There's no main method. Instead, it just contains fragments of code, right? So here's a line of code that computes what looks like to be the number of radians equal to 270 degrees, right? This line here, it looks like it's trying to print something. So it'll print the number of radians, right? This line here prints a blank line. And then there's some more code here, right? So we try to convert the number of radians to degrees, and then so on and so on and so forth, right? I can run this complete cell, right? And now the output appears here, right? You can, again, it's a code cell, so you can just go in and edit it if you want to either compute something else or change one of the lines of code or whatever else it is you want to do. And so the notebooks are interactive, which is nice, right? You can go in, you can look at some code, you can run it immediately, right? You don't have to type it into into your Java IDE and then compile it and then debug it and run it. You can just type whatever code is you want to experiment with straight into a code cell and run the code cell and see the result. And so the ideal use of the notebooks is to use them in an interactive way, right? Go in, read the text, right, and then read the code that's in the cell, and then play around with the code in the cell to make sure that you understand exactly what is happening. Also in the notebooks, you'll find they all contain exercises. Sometimes the exercises are in the middle of the notebook. Sometimes they're at the end. So down here, oh, here we go. We've got more exercises down here. Usually there's a place in the notebook for you to also do the exercise. You can, of course, do the exercises or any of the notebook cells in your IDE instead. But if you want to, you can also do them in the notebooks. If you go back to the table of contents, you'll see that at the end of every part, right, so part 1, you'll see another notebook labeled exercise solutions. So the exercise solutions notebook contains all of the exercise solutions for all of the notebooks in for each part of the notes. Right, so here you can see that for the dynamic versus static typing notebook, there's the answer to exercise 1, there's the answer to exercise 2, and so on and so on and so forth. Right? So you get lots of exercises to do, and you get all of their solutions. And so that's the quick introduction to using the Jupyter notebook, for the course. All right, so what is this course all about? So that's the calendar description up here. But really this course is about learning how to program in this language called Java, which is an object-oriented programming language. So what is object-oriented programming? So it's one of the most widely used programming paradigms. So a paradigm is just a style, I guess, of programming. In CISC121, you learned mostly what is called structured programming. So in structured programming, typically what happens is you have some data living in a Python script somewhere. Right? So normally in 121 you'd make a little Python program, you would have some information in the main part of the program, and then you would call some functions to operate on that data. Right? You're allowed to use loops, you're allowed to use conditional statements, so if statements, and that controls the flow of your program. Right? So a program basically consists of some loops, some if statements, and some function calls. In object-oriented programming, the way an object-oriented program organizes information is different. So instead of the information living in one place, or perhaps in a few scattered places, in an object-oriented program, the program is made up of what are these things called objects. Each object can have what's called state or information. And furthermore, each object has what's called behavior or methods. A method resembles a function in Python. So I can call a method using an object, and typically the method will operate on the information that the object is holding. Right? Objects can interact with one another by passing what are called messages to each other. The messages are just calling methods that belong to other objects. There's many other kinds of programming paradigms. You might, if you take, there's a third-year course where you actually learn about several different programming paradigms. Some of them are quite different than object-oriented programming or structured programming. So what's Java? So Java is a general-purpose cross-platform object-oriented programming language. General purpose means you can use the Java language for many different applications. It's better for some types of applications than others. Cross-platform means that it runs on many different computing platforms. Java was created during the early 1990s. Some of the goals of the Java language were to address issues with the dominant programming languages at the time, which were C and C++. These are still dominant programming languages to this day. The primary goals of the creators when creating the Java language are listed here. They wanted a relatively simple language that was object-oriented and familiar. And so the familiar part here means that the basic syntax of the Java language is similar to that of C. And the reason that was one of the primary goals is to try to convert C programmers over to Java programmers. They wanted the language to be robust and secure. And so this was important because at the time, in the 1990s, this was when the internet was starting to become prominent. And so as soon as you have networked programs or programs that run over a network, security now becomes an issue. They wanted the language to be architecture neutral and portable. So you could write your Java program on one kind of computer, and with relatively little work, hopefully it would run on a completely different type of computer. They wanted it to run with high performance, and they wanted it to be interpreted, threaded, and dynamic. So these are terms that you'll learn about later on in a second or third year course, probably a third year course in your operating systems course. Where is Java used? So Java is most commonly used in what's called enterprise software. So this is software that's used by large organizations. Typically, it's software that an ordinary person would not come across in their daily life. So things like payroll or the internal software used by companies the internal software used by typically large companies. It's common on the server side. So in other words, it's common on networked applications. You may have heard of big data. Java is very common in that area too. Embedded devices are typically small computing devices or small devices that don't necessarily appear to be a computer. Typically, they don't have a screen or a keyboard. So these would be things like your internet modem, for example, or some small electronic device, perhaps like a camera or something like that. It is used for some scientific applications. In particular, NASA uses it for quite a few things. And it is used for some types of video games. Although if you're seriously interested about programming video games, then you probably don't want to use Java as your primary programming language. Certainly, if you want to do it for a career, it would be difficult to find a game studio that used Java as its primary language. If you click on this link here, you'll find a web page written by someone who works for Oracle, which is now the company that has claimed stewardship over the Java language. And they talk about the 25 greatest Java apps, in their opinion, that have ever been written. Okay, so you might ask yourself, why aren't we learning Python? Because you just spent a whole semester learning Python in CISC121. So the answer is it's good for you to learn different programming languages, right? As a professional developer, It would not be unusual if you routinely worked in 2, 3, 4, 5, or many more programming languages. So the more the more languages that you know, the more useful or productive you'll become. Perhaps more importantly for your undergraduate education is that it's easier to transition to C and C++ from Java than it is to transition from Python to C or C++. And C and C++ are two of the languages that you will probably encounter in your upper year CISC courses. Okay, so if you, because you were using Java in this course, you need to get Java set up on your home computers. Instructions are on OnQ. Let me just quickly show you that as well. So back on OnQ under Content, Course Readings and Resources here. You'll find a link here. So installing the course software if you're on Mac, installing course software if you're on Microsoft Windows, and then you're going to be using a Java integrated development environment called Eclipse. And so that link there takes you to a video that shows you how to use Eclipse to create a Java project and the Hello World program. And so that's useful here if you've never used Eclipse before. You don't have to use Eclipse in this course. So if you've programmed in Java before and used a different IDE, it is possible to use that IDE, especially if it's a professional IDE as opposed to a educational IDE. So for example, NetBeans would be appropriate. You can make Visual Studio Code work, but the only IDE that we support officially in the course is Eclipse. So it's the only one that we can help you with easily. If you run into problems using a different IDE, there's a good chance that we won't be able to help you with your problems. And we've demonstrated the Jupyter notebooks already, and so I'm going to skip ahead to the next deck of lecture slides here. So this is the second set of lecture slides. So this is where we start to transition you from Python to Java. Okay, so a Python program starts running from the first line of a Python script. And that means that your program can be a single line long. Right, so the Hello World program written in Java consists of one print statement. In Java, a program that actually runs always starts running from what's called a main method. And every main method must belong to a class or interface, but ignore that for now. And furthermore, the main method has to have a specific form. So here we have a main method inside of a class called Hello World. So the format of the main method is public, static, void, main, round brackets or parentheses, and then string, ... args. Everything here is important. So the capital S here is important. The lowercase p, s, v, m are important here as well. Right? The brackets are important. The braces are significant. The semicolon is significant. There is a second form of the main method that you are allowed to use. So it starts out the same, public, static, void, main, but inside the round bracket, it's string and then square bracket, args. A Java class name should always start with an uppercase letter and contains no spaces. So this line of code here is the opening declaration of a class called Hello World. Right? And so when we give a name to when you make a class, you have to you normally give it a name. When you give it a name, that name should be in what's called upper camel case. Right? The first letter of the word is capitalized. If you have a multi-word name, every word should start with a capital letter. So big H hello, big W world, no spaces anywhere in the name. You're allowed to use letters, numbers, and the underscore in a Java name. right? Class name, variable name, method name, right? The rules are all the same. You should generally avoid underscores except in unusual cases. The unusual cases would be where it's easier to read the name where there are underscores in it, but that's relatively uncommon. Java statements end with a semicolon. This is not exactly true, but it's the easiest way to convey the idea at this point in time. So that line there ends in a semicolon. Python string literals can be single quoted, double quoted, or triple quoted. So a literal, if you haven't heard this term before, is something that you can write down, right? So a string literal is a string that you can write down, right? So for example, hello world. In Python, you can use single quotes, you can use double quotes, or you can use triple single quotes. In Java, a string literal can only use double quotes, right? So here I've got hello world, right? The literal hello world inside of double quotes. Here I've got another string literal, also in double quotes. And finally, a third literal, also inside double quotes. To print something in Python, you can use Python's print function. Now, Python's print function, you can pass it in a comma separated list of items to print. And Python will insert a space or a space or whatever other string you specify in between the things that you're printing. So for example, 2 comma plus comma 3 equals 5 will output 2 plus 3 equals 5 with spaces in between each thing that you asked the print function to print. The closest thing to print in Java is the method called println. So that's an L, that's an N, right? So that's short for print line. So the way you use print line is system.out.println, round brackets, and then you're allowed to specify one thing to print. Right? And so if you want to print multiple things out, what you do is you concatenate those things together. Well, more precisely, you concatenate their string representations together. So to print the same message as on the previous slide, I can take the number 2 and use the plus sign or the plus operator to join 2 with this string here, plus. Right? Notice there's a space before and after the word plus, and that's because when you concatenate two things together in Java, or two strings together in Java, it does not insert any other character, right? So it doesn't insert a space between the two items. So when you write something like a number plus a string, as long as one of those items is a string, Java will convert or try to convert the other item to its string representation. So in other words, it tries to take the 2 and form a string corresponding to the number 2, and then it will join it with the second string. So this will take the string 2, join it with space, plus space, and that all produces a string, right? You've now got a string plus something else, so Java will try to concatenate these two together as a string. So it takes the 3, computes the string corresponding to the number 3, and then joins these two things together, right? So you get 2 space plus space 3, right? Then you get a string plus another string. So 2 plus 3 equals, that's all the string, plus a number. So it takes the number, computes the string corresponding to the number, and then you get a string plus a string, right? So 2 plus 3 equals 5. So println can only takes one argument, and the argument is usually a string, although for the time being, the argument is a string, although println can print other things. Python variables have no type associated with the variable name. So here I can make a variable called s. I can assign a string reference to the variable s. right? Then on the very next line, I can assign what looks like the number 123 to S. And then on the very next line, I can assign a list 123 to S, right? So in other words, Python doesn't care what you store in a variable, right? You can store whatever you want in a variable. In Java, variables have a type, right? And the type of the variable is declared when you create the variable and give it a name. Once you give a variable a type, you can't change the type. And a variable can only hold values of the declared type. So here, we are saying that this variable S, its type is string. So I can store a string reference in the variable S. Right? So here I've got a string, hello world, and I can store that, a reference to that string in the variable S. Right? I can only store string references in the variable S. Right? So I can't store a number, for example, in S. Here I've got a variable called t. Its type is int. So I can store an integer value in t. Right? I can store the number 123. And here I've got, what, as a Python programmer, what should appear to be very strange, right? I've got something called a list, and then this less than and greater than sign, and then this word integer in between. So this is actually the Java type for a list of integers, right? And so that says that the variable a list, its type is list of integer. Notice on the right-hand side, there's a different, there is what appears to be a different type on the right-hand side. But we'll talk about lists later on in the course. When you create a variable in Java, you have to give it a name. The name should always begin with a lowercase letter and contain no spaces. So the convention in Java for variable names is to always use lower camel case for multi-word variable names. Right? First letter of the variable name always begins with a lowercase letter. If you have a multi-word name, then each word after the first should be start with a capital letter. Right? So lowercase s, lowercase t, and then lowercase a, capital L list, right? Because this is a multi-word name.